Last time, I showed you how to use the How to Design Data recipe to design a simple data definition. In this video, what I'm going to do is show you how to use the How to Design Functions recipe to design a function that consumes data defined by your own data definition. So this will be a function that consumes what's called non-primitive data. In this case, it'll be a function that consumes the type city name. In this problem, we're asked to design a function based on having a data definition. So the problem says, use the city name data definition below to design a function that produces true if the given city is the best in the world. And we're allowed to decide whatever best city we want. So what's going on here is that we know that the city name itself that's consumed by the function is going to be represented as a city name type here. So that lets us get started right away on our signature. This function is going to consume a city name. And let's see, we're producing true. So it's a yes-no question. We're representing it with a Boolean. So that's going to be produce a Boolean. And now what do we got to do here? Well, we produce true if the given city is the best in the world. We could start with this as a purpose. Produce, I'll just copy it. Let's see, the next step of the recipe is the stub. We'll call this function best question mark. Remember, there's a convention that the name of predicates, functions that produce a Boolean value, should end in a question mark. So we'll say best of some cn, and for the stub, I'll say false. And I'll just label this as the stub. And now we can get on to the check expects. And when we design a function using a data definition, this is a good time to go back to the How to Design Data Definitions webpage. Remember, I get to that web page by first going to the Design Recipes page and then going to How to Design Data. And then this is an atomic data definition, a simple atomic data definition, so I'll go there. And in this web page, each kind of data definition has a section called Guidance on Examples and Tests. And this gives us some hints about making check expects for this particular kind of data definition. So whenever you design a function using a data definition, go to this part of the How to Design Data Definition webpage and get some of this guidance. For our purposes now, I'll tell you what it says as we keep working. Basically says that one or two examples are enough, and that also is true of a function that produces a Boolean value. If you have a function that produces a Boolean value, you should always have at least two examples, one that produces true and one that produces false. So let's see, if I say check expect best question mark, and now I need to give some city name, like let's say Boston. And is that the best city in the world? Well, remember, the problem description said we were free to choose any best city we want. So I loved Boston when I lived there, but let me say that it's not the best city in the world. Let's use an imaginary city for the best city in the world, so no one can possibly be upset. We'll use Hogsmeade as our best city in the world. So now that is the best city in the world. And probably this is a good time to make the purpose more specific. So we'll say, produce true if the given city is Hogsmeade. Okay, so now I've got two tests and the stub. I should run, and I get that one of the two tests fail, but both tests actually managed to run. So that tells me that my tests are well formed. Both tests ran. So now we can keep going. Let me start by making the screen bigger again. So let's see, signature, purpose, stub, check expects. Now the template. Well, the way we get the template now is we're going to put a note here that says took template from city name, because this function consumes a city name. City name is a data definition that we design. So we're going to take the template right here, and what I'm going to do is copy it. I'll have this note about where I got it, and the first thing I got to do is remember to rename it. So I'll rename it to best, and now here's the template. Now let's see what I do next. This is a function that has two cases, a false case and a true case. So a good first thing to do when you have a function that has two cases is to add an if to the template. So what I'm going to do is I'm going to copy the existing template. I'll put an if in here, and for both the question and the true and false answer, I'll put the copy of the template. This is a way now of telling me, listen, there's an if, and in order to fill out all these parts, ... cn is what you have to work with. Let's see, cn is the city name. So let's see, in one case, the city name is Hogsmeade. And let's see, if the city name is Hogsmeade, then this example right here tells me I should produce true. So that's true. And if the city name is not Hogsmeade, then this example and the purpose tell me I should produce false. So that's going to be false. Let me run it. Oh, I forgot when I was up here to comment out this stub. There we go. Both tests pass. Now, let me make a couple points here. One is that you notice that there was a point in the template where this was ... cn. And then I deleted that and replaced it with true. This is an important thing about templates. Templates tell you everything you have available to work with. They don't tell you you have to use all of it. So oftentimes you'll be deleting things out of templates. Another point to make about this function is, let's think about this. This says if string equals cn Hogsmeade is true, produce true. Otherwise, if string equals cn Hogsmeade is false, produce false. When you follow a very structured approach to designing code, sometimes you produce code that's a little bit more cumbersome than it needs to be. This function could instead just be this. Let me comment out this version of it and run it again. And now that's working too. But don't worry if you produce this version of the function. This is clear and it's well tested. It's just that if you ever find yourself writing if xxx true false, that's always the same as just xxx.